Hello everyone, I'm Guoqiang Chen. I'm here today to talk about our paper HexT5 Unified Pre-training for Super-Binary Code Information Inference. Let's start with the example. It's a function for base64 encoding from a real-world project. The source code is on the left side and the binary code in assembly is on the right side. The compiler drops something in the process of compiling the source code into the executable binary code, such as the variable name, the function names, and the strings and the control structures. These are very important for understanding what the program is doing. Due to the absence of these things, it is difficult to understand the semantics of the program from the binary code. So can we recover these informative materials to help us understand the binary code semantics? Fortunately, the modern decompiler do help us partially recover the part of them. In this slide, we can observe the control structures highlighted by the blue color in the schedule code, as well as the strings highlighted by the green color. Understanding the semantics of binary code is a necessary step in analyzing the virus, the trojans, and other scenarios where the source code is not available. But given that we have access to few semantic prompts, the schedule code is still hard to read for participants. So is there any work trying to help us understand the binary code? The answer is yes. One way is binary code similarity detection. Such methods generally use a code embedding module to generate the semantic embedding of no unknown binary code, and then search into a database of known binary code to determine the code similarity based on the similarity scores calculated between the embeddings. Existing notable work including ASM2Vector, SAFE, Asteria, GMN, Palm Tree, and so on. Another way is to infer the symbolic information, such as the variable name and the function name. If we could be told that the function name of the schedule code is base60 encode, or the string variable name is b64str, it will be easier for us to know that what the function does. Existing notable works include the Dirty, Direct, FRE, SIMLM, and so on. Here is another way for information inference. It is binary code summarization. Similar to comment in source code, it allows the user to understand the functionality and other details better. For now, only BinT5 has focused on this task, which was published earlier this year. Let us summarize the limitation of the existing methods. First, binary code summarization task, function name recovery task, and variable name recovery task are inference information based on the code semantics, but they are considered as independent tasks in previous works. And second, the similarity-based method and high-level semantic understanding-based method are considered as fully orthogonal. There has been no effort to combine them to make the model more robust. And third, most of the existing methods use a low-level representation of binary code as input, such as the assembly code. They ignores the additional semantics that existing static method can bring, such as the schedule code. With this problem in our mind, in this paper, we propose HexT5, a unified pre-trained module, to seamlessly support both various information inference tasks and similarity-based detection. We also collect a new large-scale, well-formatted dataset (NSP) for our pre-training tasks and downstream tasks. The NSP dataset contains cross-module data, including schedule code, natural language, and the identifier from the source code. HexT5 employs 4 pre-training tasks, which we will briefly introduce later. And our pre-trained module can support multi-downstream tasks well. Now, let's go through the pre-training tasks we designed. The first pre-training task is mask the spam prediction. Inspired by the previous work, we utilized the basic unsupervised noising method to learn the semantics of both schedule code and commands. As the figure shows, it corrupts the code chunks by randomly masking a spam code. Then the model predicts the original text. The second text is source identifier prediction, which is dissimilar with MSP. Only the special tokens, including the function name, the variable name, and the code name, would be masked and predicted. Text to be predicted is a dictionary composed of the pair of placeholder tokens and the original identifier name. The third task is by module single generate, which is a cross-module task between natural language and the code. Since we are more concerned with the understanding of the code, so we only train the model to generate the natural language commands from the code, and do not train the module again in the reverse direction. The last pre-training task is constructive learning. We consider the binary function from the same source code function is similar in semantics, and we should push semantically similar code closer together in the embedding space and push the non-similar ones away. This task is designed for this purpose. So that's all of our pre-training tasks. Now, let me briefly describe our dataset construction. The binaries from our dataset are compiled from 51 projects from the GNU repository with 64 different cross-compilation options. The dataset is divided to 811 as training set, validation set, and test set in a cross-project manner, which is closer to the practical situation. And the test set is further divided into 119 as fine-tune set and the final test set in cross-binary manner. So we evaluate our HexT5 in our downstream tasks. On the binary code summarization task, as shown in the figure, our method outperformed the only previous work who focused the same task in T5 by a significant advantage. On the variable name recovery task, we conduct experiments on our NSP dataset and their dataset. As shown in the figure, no matter which dataset and no matter what dataset division strategy, HexT5 outperform previous method with higher accuracy and a lower character error rate. So on the function name recovery task, we also employ two datasets. The result is similar with the last one. Our method shows better performance than others. However, it should be noted that on both the variable name recovery task and the function name recovery task, all the methods do not have high metrics on the cross-project manner, which suggests that the capability of existing method is not sufficient in the real world. At last, on the similarity detection task, we compare with existing method on the one-to-many search task. XA plus XO plus XC means that the target code and the query code are across all of the compilation options. The results show that HexT5 can retrieve the best candidates accurately in a large code base. We also want to analyze the limitation of our method in the hope of providing insight for subsequent studies. The first thing is the limitation in the cross-project scenario. As we mentioned in the evaluation, all methods, including our HexT5, have not satisfactory performance in practice scenarios. And the lack of semantic diversity is also a problem that needs to be overcome. Although our dataset NSP already contains 5 million different binary code, it still has insufficient diversity compared to the widely used public source code dataset, such as the code XGLUE, which has almost 6 million totally different functions. Furthermore, we observe the inconsistency in Collie prediction. Specifically, the functions are predicted to different results in different colors. Now, let me summarize our work. We formulate various innovative pre-training objectives that capture the semantics of both pseudocode and high-level natural language and align them. And we implement HexT5 and evaluate on 4 downstream tasks. The results show that it outperforms existing methods. And we create a new large-scale, well-formatted dataset, NSP, for our pre-training and downstream tasks, with automated approach for collecting comments of decompiled code. And we also note the difficulty arising from data diversity, as well as the issue of contextual consistency. We call for more efforts on these issues. That's all of my presentation. Thank you for your time. If you have any question, please feel free to tell me or connect us by the emails.